Hello everyone and welcome to the Scala tutorial video. This video is suitable for developers who have already learned the programming language, for example Java or Python, and for those who want to learn Scala. Scala is object-oriented, functional and very expressive. There are a lot of things which you can do with one line of Scala code. I will give a quick overview of most of the Scala features. As you can see, I'm developing with Visual Studio Code and I have installed the Metals plugin. Here under Extensions, you can search for Metals and Scala Metals. I have already installed the plugin. Also, I have installed the SBT tool, which is needed to build and run Scala projects. Also, I have installed the JDK. Scala applications run on the JVM, therefore you need to install the JDK. Once you have everything installed, you have the icon for the Metals plugin here. And there you have the button to create a new Scala project. And there's a variety of templates which generate a project for you. I can do with a simple Hello World project. Then I select the folder where I want to create the project, and then I enter the name, Learn Scala. Now the project has been created and I can open it in another window. The Metals plugin should detect a Scala project. Now you have several files here. You see the project generator has generated a main class. We see here an object called main. It extends app. So this is the main function, the main entry point for our program. The code which we want to get executed goes into this project. You see there's already a print line which prints out Hello World in the console. The Metals plugin creates those little buttons where you can run and debug the main class. I click on Run. And you see the console output Hello World. Let us first start with variables and types. The first thing we want to do is defining a variable. We need the keyword var, and var means it is a mutable variable. Then the name of the variable. Then you can specify the type with colon. I define an integer variable and I can assign a value. So now we have defined a variable named a of the type integer with the value 1. Since it is a variable, with the keyword var, we can assign another value to the variable. And we can also define an immutable variable. For that we use the keyword val and name it b of type integer and assign the value 1. And if you want to assign another value, then we get a compile error, reassignment to val. We can also omit the type definition. Let's say we have a variable named c. We can omit the type definition and assign it a value directly. And the compiler infers the type. It notices that it is an integer value. So let us try all the basic types. Var of type long. This is a long type. We also have the type float for floating point numbers. Also we have the type double, also floating point number. For the float type we need to set the f at the end. Also there are big variations of those numeric types. For example, we have the big integer, which has a larger scale. And also the big decimal. And there's also the Boolean type. We can also apply operators on the variables. We have the variable a, and we would like to increment it by the value 1. With print line, we can print a line to the output console. This way I will print the value of the variable a. Then I click on Run, and you see that it has the value 3. Let's subtract a value. You can also do multi-assignments to variables. Let's say we have val and a1, comma, a2, a3, a4. They are all of the type integer and they all get the same value assigned. There you see that I have 4 times the value 300. You can also work with strings. Let's define a string, string1 of type string equals hello, and we have var. This time I omit the type definition. And we can print them out, print line. Let me delete this. And you see hello world. And of course there's more what you can do with strings. For example, you can access characters at specific positions. Print line char at. I want the character at the position 0 and the character at the position 1 and the character at the position 2. And you see HEL. Strings have more functions, for example, replacement. I would like to print out the first string concatenated with the second string, and there I do a replace. The old character is exclamation mark, and I replace it with 3 exclamation marks. Now I have hello world with 3 exclamation marks. Let me delete this. The next noteworthy thing is using tuples. We have this, let's say coordinates, and I use these parentheses and add some values, for example 5.6 and 7.8. Tuples contain a fixed amount of elements. Each of them has his own type and they are all immutable. Let us print this out. And you can also access all the specific elements. With _1 I get the first element. And with _2 I get the second element. Each tuple element can have its own type. Here I have the type string, the type integer, the type boolean, let me print this out. Hello 5 true. And you can create tuples with up to 22 elements. And here you can access all elements. Underscore, and you see it goes up to _10. Let us try something else. Let's say we have a person. The first element is a string, the second a number. And what we can do now is we can assign this to this name, age, person. We assign the items to these values, name and age. And we can also access them. Name, Alright, now we are moving on to string interpolation. For that, let us define two variables. First name and we would like to print out this. And for string interpolation, we must specify a string literal. We do this by typing s, quotation mark, and within this string literal, we can use these variables. Let's say I want to type my name is last name, and you see autocomplete works here. And let's execute it. My name is Bond, James Bond. Within this string literal, we can access all variables and members and functions of objects. I would like to call a function of an object now. Let me type this, print line s random number is. And here I would like to use the random number generator with the symbol $. And I use curly braces because I want to call a function of an object. And I use random of the package Scala util with the function next int 100. Let's execute this. And you see this is the output. And now let's move on to the if statement. Let's create a variable. And you type if with parentheses and then the Boolean expression. You can use either curly braces else or without curly braces. Let's run this. And it says true. You can also do the same thing with the ternary operator. Print line. And the ternary operator is a single line if statement. You can say if each case of the if statement returns a string value, which is then printed out. There you go, I have 2 times true. Let's negate this. True and false. And we are moving on to the loops. Let's define a variable I. And we can do the old school do while loop. Do while. And increment I by 1. While I less than 5. Let's run this. And you see do while 5 times. And of course the classic while loop. And there you go. Let's delete this. So for the for loop, you type this for, specify the iteration variable, and here you assign a range. Let's say we have a range from 1 to 10, and we can do curly braces and print line or 2 string literal I. And also another alternative is to do this. You have I, you assign 0 until 10. For until I. And let's see how it looks like. So that means, so with the to word, we iterate inclusive until 10, and with the until word, we iterate exclusive until 10. So we stop at 9. And the for loop can actually return something. Let us try this. Var x equals 4. I use I iterate from 1 to 30, and then I use this keyword yield, and I type I times I. With the yield operator, you collect values. Once the for loop has finished, it returns all gathered values in an iterable of the same type what you are iterating. That is, if you iterate a list, you get a list as a result. If you iterate an array, you get an array as a result. The compiler tells me that I get an indexed sequence, which contains integers. And that means I can iterate the variable x. I use I, and I iterate over x, and I print line I. And let's see how it looks like. And there you go. And also I can use guards within the for loop. I just type here if I, for example, modulo 3 equals 0, then I yield I. And that means I will only iterate over values which are dividable by 3. And that means in the result I should only see numbers which are dividable by 3. And you see, that's correct. Furthermore, we can use several iterations within a for loop. Let's do this. For, and I iterate over I, 1 to 10. And I can use another iteration here. I iterate over j, and it's 11 to 20. And I print line I and j. And what that does is it starts iterating with I, and for each value of I, it iterates over all values of j. That is like nested for loops. And let's see how it looks like. The I value is 1, and then all the j values, and then the next value for I, and then again all j values. Within Scala you can use Java libraries. For that, let me try the local datetime API. Let's define var now, and it's of type local date time, and you see it's from the package Java time, and I can just do this local date time now. And if I would like to print this out, I use this now formats, and I need a datetime formatter of pattern. And then I run this. So this is the date. In this import section, you see that I've imported Java classes. This way you can use all available Java libraries. So let us move on to functions. We can define a function by typing the keyword def, then the name of the function, I call it sub, and then with parentheses you can specify parameters. The first parameter will be a of type integer, the second one will be b of type integer, and the return value of the function is also an integer, and the body of the function is within curly braces. So in Java, you would need to type the return keyword to return the result. But in Scala, the last executed expression within the function is the return value. So I can just use this a minus b, and a minus b will be the result value. So let me call this function. I would like to print out the result. I use sub 5 minus 3. Let's execute this. And you see 2. What you can also do is you can call the function and then name the parameters. You can say, for example, b equals 3 and a equals 5. You can also specify default values for the parameters. Let's say a is the default value 1 and b has the default value 0. You can call the function like this without any parameters, and then I should get a 1. Or you can use it like this, b equals 10, then I should get a minus 9. It is also possible to return a function from a function. Let's define this. I define another function and I call this function provider, and it has no parameters. And now I need to define which function I want to have. I want to have a function which has 2 input parameters. Each of them is of type integer, and the function must return an integer value. I define it this way, int, and the method body is this, and I can actually return the sub function because it has 2 integer parameters and an integer return value. And I can do this way. I just type sub, I return the sub function. So let me try this new function. Let me print out the result, and I call this function provider function, and then the result value is another function. I can call this new function by applying the parameters, and I set 10 and 7, and that would mean I would get 10 minus 7 as a result. Let's execute this. There you go. I can do this also another way. Instead of returning the sub function, I can specify a lambda. And lambda, I type this. I have the input parameter a of type integer, b of type int, and I use this arrow, and I return a minus b. So lambdas are like inline functions. This is the same as this. And if I execute it, I get the same result. There you go. We can also make this more compact. This is only one line. That means I can get rid of those curly braces. And here as well. And now you see no compile errors. And Scala provides a way to specify nested functions. For that we just do this. I type again div, I name the function mul, and I also have 2 input parameters, each with the type integer. And the return type is integer. And here I use curly braces. And within this function I can specify another function. I can use this, define multiply. And of course it also has 2 input parameters, int and here I just do a multiplication of a and b. And I made a mistake here, I need to do this. And then I can call this nested function. I want to test it out, print line mul 3 and 4. And 3 times 4 equals 12. I call the mul function, Within the mul function, another function is defined, the multiply function, and this function is being called. So there's even more. You can use functions as input parameters for other functions. Let me define another function and I call it apply this. And the input parameters are a of type integer, b of type integer, and the third parameter is, I call it apply, and it is a function of this type. So the third parameter is a function of type two input parameters of type integer, and it returns an integer. The return type of the whole function is also integer, and this is the body. And what I can do is I can call this function here with the given parameters a and b. And the cool thing is we can use this function to call our sub and mul functions. We do this by typing this, apply this. I use 5 and 3 as input parameter and sub, and also print line, apply this with the same input parameters 5 and 3, but I call multiply. This line should return 5 minus 3, and this line should return 5 times 3. Let's try it out. 5 minus 3 is 2, and 5 times 3 is 15. There's even more what you can do. You can have functions with multiple parameter lists. Let me define this function. Apply this to. Parameter 1 is a of type integer, parameter 2 is b of type integer, and then you can use another parameter list and say you have parameter apply of type function. Int, which returns integer, and the overall result is integer equals this, and you can do the same as here. This is the first parameter list, and this is the second parameter list. So let us call the second function print line. I call apply this to. I use 5 and 3 as input parameter, and the second parameter list is sub. Five, 3, and mul. The second function should behave the same as the first function. That means the output of this should be the same as this. And let's check it out. 215, 215. So let's have the last function lecture. This time I would like to show the implicit parameters. Let's define a function, add constant. It has one parameter of type integer, and I add a second parameter list, and this time I use the keyword implicit, and I name the parameter add of type integer. It returns integer, and what I do is I return a plus add. Let me try to call this function, add constant. So what does implicit parameter mean? That means when I call this function, I do not need to add this parameter. When I call this function, I provide this parameter, but I do not need to provide this parameter. And that means I call add constant with 5, and there you see a compile error, and that means could not find implicit value for parameter add. So what Scala does is it tries to find a variable which fits for this implicit parameter. In order to make it work, I need to provide an implicit variable so it can use for this implicit parameter. And that means I use this, I define an implicit variable, I name it constant with the value 100, and the compile error is gone. So what now should happen is I have this constant 100, it will be used as an implicit parameter, and that means I will get 5 plus 100. Let me execute this. And there you go, 105. Okay, now we are moving on to arrays. We can specify an array with this, defining a variable. I call it numbers, and using array, and we are instantiating the array with numbers, let's say 3, 4, and 7. This is an immutable array. It has a fixed number of items. You cannot remove them, but you can replace them if you want. Let me print this out. I iterate it in a for loop. I iterate over x in numbers and print line x. Let's see how it looks like. Then I get 3, 4, and 7. And then I would like to replace an element. Let's say numbers. I would like to replace the element with the index 0. I would like to set it to 100. And the third element should be 57. And then I iterate it again. X. Let's see how it looks like. And you see 3 has been replaced with 100, 7 has been replaced with 57. And we can do mutable arrays. Let's say I have this. This time I use a variable called words, and it's an array buffer, and it is of type string. The square brackets are generic types. I can say that this array buffer contains strings, and it's an empty array. And then I can do this. I can append items with plus equals. I append the word book plus equals chair words plus equals school. And of course I can iterate it. X over words and print line X. Book, chair, school. You can also iterate over all values of the array by using this. Type words and then for each. And here you need to specify what you need to do with each value. And I specify a lambda. I have an I, and I use it to print line I. And I run this. This is the for loop, and this is for the for each iteration. And also to make it more compact, we can just use this here. I remove this and just pass the function print line. We have learned that functions can be input parameters for other functions. The for each function, it requires a function which has a string input parameter and a unit output parameter. A unit output parameter is similar to the void type of Java. That means it is nothing. And let's execute this. And you see for each item it prints out the value. And we are getting to the collections. We also have lists. Immutable list. And let's say I am creating a list. This is an immutable list, type integer, and it contains these values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of course we can do the same as with arrays. For x within immutable list, print line x. And this is an immutable list, that means we cannot remove any items. And of course there's a mutable variation of the list. Let's say I have a mutable list and it's of type list buffer, and the generic is type integer. The generic type ensures that I can add only elements of the type integer and make sure that it's imported correctly here. And I need to, so I have instantiated an empty list buffer. I can do this, I can append an element, and you see only type integers allowed, so I can append a 1. I can do it in a fluent way, I can append more, 2, 3. And what I can do is I can append a whole list as, say this, append all, and it's and I append another list with the values 4, 5, 6. And let me print out the result, mutable list for each, and print line. And you see I have a sequence of numbers from 1 to 6. The list collection provides concatenation operations. Let me try this. I define another variable, name it x, and it is 0. And then I can use this operator. I use this operator with mutable list. And what that means is I prepend the 0 on this list. That means the first element of the list will be the 0, and then 1 to 6. I can also use this operator, colon plus and 7. And please note that the colon must be on the collection side. That means here the left side is an integer, the right side a list. And here on this operator, the left value is a list or a collection, and the right side is an integer. And I can also use this colon. The result of this will be a collection and plus plus, and that means I add all values of this list, and that is 8, 9, and 10. And with this concatenation I have values from 0 to 10. And let's iterate this x for each, print line, this, and let's execute this. And there you go, 0, 1, 2, up until 10. The list has more functions. Let's say x, and then I call the map function. And I can use a lambda. Let's say I have I, and I apply this, I plus th, and for each print line. And that means every value which I iterate, I map it to a string value. I concatenate the value with the string, and then I print it out. And you have this. Or you can do it this way. You can use the underscore. This is the placeholder for whatever item you are iterating, and plus this string. And this will be the same result. Let's execute this. And there you go. And maybe you want to filter the elements. Let's say before you do the mapping, you do filter. And this is, you can also use the placeholder, modulo 2 equals 0. So with this expression, we filter only for those values which are divisible by 2. Modulo 2 equals 0 means it is divisible by 2. Let's execute this. Alright, 0, 2, 4, 6, 8, 10. And now let's try maps. We do this by defining a variable, total country, and we have a map, and we can also insert the values. This is a map from hotel name to country. The first hotel name is Plaza, and the country code is Spain. Then we have this hotel, and the country code is United States, and another hotel, Premium Plaza, US, and this hotel here, Family Hotel in the United States, in Germany. So this way we have a map which maps a string value to another string value, and we can do this. You can say get, and I would like to get the country code for Premium Plaza, and I want to print this out. And it says US, and you see the return type is an option, and an option may have a value or may have not a value, and we can also iterate over all values, for example with a for loop again, and let's say x over this map, and as we see that the compiler tells us it is a tuple. We have a string tuple, and we have already learned tuples. Let's do this, print line x underscore 1 to get the key. Let's do the string literal way. Alright, x underscore 1, x underscore 2, okay, we have iterated all tuples, and of course we can do this fluent way, hotel country for each, and here I can do the same. I can just call this variable x. X is a variable of a tuple, and this here, let's remove this for loop. Let me add this one here, for each. Let me execute this. And you see, with the for each function, I'm iterating all the values. And of course, we would like to add another value to this map. It turns out I have used the immutable map. And in order to use the mutable map, I just import this one here, Scala collection mutable. By default, Scala uses the immutable map. And now I'm using the mutable map. So I can use this, and I use the append operator, and I append this. Let's say I have a hotel named Ocean with the country code DE. I've made a mistake here. And let's see how the output looks like. Here you see this is the new hotel. So just for clarification, this is another syntax for creating a two-dimensional tuple. Let's try this. So you see, we have created two equal tuples. Also, you can make this iteration much more compact. You can use pattern matching here. Let me type this. So in curly braces, I can type case, and then I specify a tuple with these variables, and then arrow, print line, string interpolation, name, country, and let me execute it. There you go. So this is called pattern matching. You can unpack a tuple, you can assign each element a variable name, and then access the variables for each value. I will explain pattern matching later. And also note that the map has generic types. The compiler tells me that this map is a map of string values. I can specify this with square brackets. So if I would have a map of string to integer values, then that would be string integer. And it's time to do some object-oriented programming. Let me introduce the traits. Let's create a trait, we call it fruit. And a trait is similar like an interface in Java. You can define methods here. You cannot instantiate traits. Let me do this. I define a function which call eat. And it returns a unit value. That means it returns void, nothing. And traits can also contain members. I say it has val calories of type integer. And we can also define classes. Class apple. So a class is something what you can instantiate. Let me try this. New apple. And you see I have this apple object. Run this. And of course you can extend something. A class can extend trait, and traits can extend other traits. Let me extend the fruit trait. Fruit. And you see the compiler shows me an error and it says missing implementation for two members, for the calories variable and for the eat function. And in order to implement the eat function, I can do this in curly braces. And I say override def. And I simply do a print line eating. And it tells me I need to implement the calories variable. And I can do it with a basic class constructor. You define a class constructor similar like function parameters. So here with parentheses, I define val calories of type integer. And you see the compile error is gone, but now I cannot instantiate the apple. And I have this argument. I need to provide the calories argument in order to instantiate the apple. So let's say it is 50. Let me try this. I just call the eat function. Let me extend this. Let me type here calories. All right. And similar like in functions, you can define a default value for a member. Let's say the default value is 35. And that means you can remove this constructor. You can just call new apple and it will get the default value 35 for calories. And also you can specify more parameters for the constructor. Let's do this. I'd say it is a var gram of type integer, default value 10, and a var color of type string with default value red. I add it here, gram color. And also similar like in functions, I can give name parameters. I say I want only to set the color and it is green. And now I have a green apple. And defining parameters in the constructor automatically creates fields in the class. Here I have the var gram and the var color. I can do this, apple gram. and change it to 13. There you go. And if you want to have class compositions, you can use mixins. That is, you can extend from several traits. Let's just create another trait. I call it pom fruit. And it has only one method. And the apple can extend fruit and pom fruit. With this, for this I use the with keyword, pom fruit. And the compiler tells me I need to implement this method. Override def. So now I have this apple and I can call do something. I'm going to use a print line. Let's run this. All right. And with this we can create compound types for function parameters. Let me delete this. And let me create several traits. Let's say we have the trait animal, the trait pet. Note that I am omitting the curly braces. And we have a class cat extends animal and mixin with pet. And we have a class tiger extends animal. So we have this cat, which is extending animal and mixin pet. And we have a tiger, which is just an animal. And I am defining a function. Let's say define feed. And it requires one parameter of type animal. And I'm just doing printing out feeding. And let's see, we can call this function for a cat and for a tiger. Say what it does. So it says feeding 2 times. It is feeding a cat and tiger, but I can define a compound type. I can say animal must be a type of animal with pet. And you see, calling this function for tiger, I get a compile error. Type mismatch found tiger required field with pet. Since a tiger is an animal but not a pet, this will fail for the compiler. Let's try this. And we can also define nested classes. Let me define a class, I call it A, with a value A of type integer. And this class A contains another class, a class B. And you can only create an instance of this class B from within the class A. So I need to define a function, create B, and it returns a class B, and it is just calling the constructor of B. And that means I can do this. This is how I create an instance of class B. You see, the compiler tells me it is of type B. And we can also define case classes. For that you need to use the keyword case and then class. And I name it article. And the case class requires only parameters. let's say I have parameter title of type string, author of type string, and pages of type integer. And case classes are like immutable objects. When you have an instance of a case class, you cannot change the values of the members. And you create an instance of the case class like a normal instance of a normal class. Article. So the first parameter is hello world. The author is J.J. Smith. And it has 100 pages. And if you print it out, the article, and it looks like this. You can access all those values, but you cannot change them. Let's say I use string interpolation. I want the title and article author. I need to use the dollar symbol. What you can also do is you can create a copy of this instance. Let's say I want to have this, and for that I just call the copy function. And if you just do a copy, you have the exact same copy, but in the copy function you can override values. I want to say that the title is my awesome article. And let me run this. And you see, I have created a copy of the previous article, and I have changed only the title. The author and the pages remain the same. Alright, it's time to define an object. You see this keyword object means you are defining an object, and objects are singleton instances. That is, you have only one instance from an object, and it is suitable for creating utility classes. Let's say I'm creating an object named coordinate utils, and it has only one function. And it returns a tuple of integer and integer. And let's say it's just 1 and 7. And what that means is I can call this method without creating an instance of coordinate utils. Let me just print line coordinate utils create coordinates. So this is the result. That means it's like static functions and members in Java. And there's more what you can do with objects. You can define a function as an object. Let me delete this, and I define another object. Let's say I call it negate. And then I define a function with the special name apply, and it has an input parameter of type integer, and it returns an integer. And what it does is it negates the value. The function name apply is like a special keyword. We have defined an object on which you can apply a value and you return another value. And you can do it by doing this. Let me print this out again. And I just do negate, and in parentheses I provide a value, let's say 7. And this will call this apply function, and then I should get the negated value. And you see I get -7. I define a class holder, and in this square brackets I specify a placeholder for a generic type. and it has one constructor input parameter, value of type A. So A can be anything, it can be any type. And I define a function getValue. And the output type is also A. So I just return value. We have already seen generic types in collections. That means you can specify what kind of type the holder contains. So let me create two holders. Val string holder. The generic type is string and it contains hello world. And another, the int holder of type int, and it contains the value 42. And if I print it out with string interpolation, string holder get value and int holder get value. Let's execute this, and you see hello world and 42. And let's move on to another topic, the self type. And for that I define another trait, person, and it has one value name and another trait, the speaker. And self type is a way to mix in a trait to another trait without extending it. And you can do this by typing this person and then use this arrow, and that means that the scope of the trait person moved into the trait speaker without actually extending it. And that has the effect that I can use the name value in the speaker trait. I define a function say something type string, and I print line with string interpolation, and I can use the name variable from the person trait without extending it. And then I would like to implement this trait. Then I should have a class, and I call it news announcer, and it extends speaker. And you see the compiler throws me an error, self-type news announcer does not conform to speaker self-type speaker with person. And what that means, I must also mix in the person trait with person. And then it tells me another error. The class news announcer is missing the implementation for name of this person trait. I define a constructor parameter for news announcer name of type string, and I just simply say val name equals announcer name, and this way I override the person name with the announcer's name, and then I can call this function of the speaker trait to say something. So let me do this, val news announcer and his name is Peterson, news announcer say, and he says so much to say. And then we should see the output of this string here. And it says Peterson, this is the name of the person, says so much to say. And now let's try implicit classes. Let me define an object, let's say help us. And implicit classes must be defined of another object, class, or trait. And you use this keyword implicit class, say this with the constructor parameter times integer, and it has only one function, say string, and it does not have a return value. And what I do is I do a for loop, I over 0 until times. The times value is from the constructor, 0 until times, and I just do print line. And implicit classes are a way to call functions without actually accessing this class here. And in order to make it work, I need to provide an import, and I do this import helpers, and I just type the placeholder. With this placeholder, I import everything from the helpers class, and that means this implicit class as well. And what I can do now is I can call this function without actually accessing this class here. And I would do it with say, and it says I am implicit, and the compiler tells me an error. I actually need to provide this value here, and I can do this by setting it here. So what that means is I have this integer value 5, I use this as this value here, and I'm calling this function of this implicit class. So what I get is I get 5 times this line. You see, 5 times I am implicit. I can also combine it with implicit parameters. We have already learned implicit parameters of functions. You define them in the separated parameter list with the keyword implicit, and I call it upper of type boolean, and the compiler tells me that he has no access of an implicit variable, and that means I define an implicit variable of type boolean and say it is true. Okay, I need to provide this keyword, and that means the say function has access to this implicit variable over this implicit parameter. And I can use this implicit parameter with an if statement. If to upper, then to uppercase, else print line without uppercase. Let me execute this, and you see it's working. Alright, we can now move on to defining operators. Let me remove this. We have already applied operators like plus, minus, or concatenations. We can actually define our own operators. It is as simple as defining functions. Let's say I have a case class, which I call vector, and it has an x value, a y value, and a z value. And it contains functions, and you can use any symbol to define a function. That means I can use a plus symbol and apply it on another vector and return another vector value, and that would mean I am creating an instance of the case class vector by adding my own x value to the other x value, and for y and z the same. And there you go, now you have defined an operator. We can test this by doing this print line vector, let's say 1, 2, 3, plus another vector 3, 2, 1. And what do we get as a result is vector with 4, 4, 4. Okay, now we are moving to the last chapter of this video, the pattern matching. The pattern matching is like a switch statement in Java. You can define it in all different cases, and the pattern matching can return values. Let me define a variable. Val x of type integer is, and I use the random number generator with next int of up to 5. And on this variable x, I can apply match, and then in curly braces, the pattern matching. I can specify a case. In case it is a 0, then I return a string with value 0. In case it is a 1, I return a string with 1. In case it is a 2, I return a 2. And also I can define a case for any other value with this placeholder here, with this placeholder underscore. And I can say in all other cases it is other. And I can assign the result of this match to another value. And then I would like to print out the result. And let's see how it looks like. And here you go 0. 2. Let me do this with the string literal. X is $result. Let me try something else. Let's say I have a list of tuples. One, 0, 5, 4, 7, and 3, 12. And I can iterate this list with for each. And here I can also apply the pattern matching. I can specify a case, and I can extract the values of each tuple by defining this here. Left, right. And then I can access left and right with these variables for each tuple. Left, and let's see how it looks like. And there you go. So with this kind of case statements, you can extract the values of tuples or case classes and assign them to variables. With pattern matching, we can also match on case classes. I have prepared a much more complex example. Here I have a trade book, and I have several classes which extend the trade book. I have a non-fiction book. It implements the members of the book and specifies another value topic. I have a novel with genre. I have a biography about a person, and I have a book jokes. And let's say we would like to match each book and extract the content of each book we are extracting. For that, I define another function and of type book, and it returns a string value, and the body is this. And for that, I can apply pattern matching on the book variable, match. And here, for all the possible books, I can specify cases. Let's say I have a case of non-fiction. And here you see I am extracting the values of the book and assigning them to these variables. And I can return string interpolation. I just use title and also the topic. And if we would like to skip some of these parameters, I can use this placeholder because I do not need the author. I only need title and topic. I can also specify another case for novel. And I would like to skip title and author because only the genre is important. And return genre. Also the case biography. Let's say the author is uninteresting for me. I can return the title with about person. And also I can specify a default case. For any other cases, I just return unknown content. So let me test this function here. I would like to print out the result and extract content. And I provide an instance of nonfiction book. Let's say the title of this book is Quantum Computing for Dummies. And the author is J.J. Smith. And the topic is quantum computing. And in that case, this case will be triggered. I have a nonfiction book and I will get a result of the title with the topic. Let me execute this. And you see quantum computing for dummies dash quantum computing. This is the result of this pattern matching. I can also do more. Extract content. Let's say this time I have a novel. And the novel has, the title is The Journey of Willie. And the author is J.J. Wilson. And the genre is an adventure. And let's see how the output looks like. I should get only the genre here. And you see it's only the genre adventure. And let's try another one. Biography. And let's say the title is His Only Chance. And the author is J.J. Smith once again. And the person is, I don't know, Jerry Wilson Smith or whatever. And let me see the output. And you see His Only Chance and this person. This is the result of this case. And also I have another book. This is the jokes. And I should get this one here. Print line. And jokes. And the title is Top 100 Jokes. And it's from Anonymous. And let's see what the result is. Unknown content. So the pattern matching is much more powerful. You can provide guards, so you can match only on values which satisfy a certain condition. You can do this by adding here an if statement. For example, on biography, I would like to have the person to lowercase, and it must contain the name Jimmy. And that means I permit only biography books where the about person field contains this word here. And what does that mean for this biography book? It does not contain the word, so I should get the default case. Let me execute it. And you see unknown content 2 times for the biography and for the jokes. And let's say I add here the name Jimmy. And let's see how it looks like. Okay, and now you see that this if statement was true, and I did return this string here. So let me try another example with regular expressions. Let's say I define a regex, and it is of type regex of Scala util matching. And you can define regex with this. It is your typical regular expression, and with this suffix .r, you see that I have a regular expression. This is a shortcut to create a regular expression. And I can apply this regular expression on a string. Find first in, I am interested in the first finding of this string. And let's say I'm typing in this and then capital H and this. The goal of this regular expression is to find capital letters. I apply this regular expression on the string, and you see there's one capital letter, the H. And the result value of this function is an option. That means you may have a value or you may have not a value. And you can also process this with pattern matching. You can apply match here, and then you have a case sum. That is, you get a value, you assign it to the variable value, and what you do is you print it out. And I found value. And also you need to specify another case, the none case. That means the regular expression did not find anything. And for that, you just print out found nothing. Let me execute it. And you see I found the H. Let me remove the capital H. And then I should have found nothing. And you see, I found nothing. Alright, that's it with the Scala learning session. Scala still offers a lot of things which you can learn. Thanks for watching my video and have a nice day.